Okay, so let's do problem 21. An amount of 49,000 is borrowed for 11 years at 5% interest compounded annually. If the loan is paid um, if the loan is paid in full at the end of the time at the end of that period, how much would be paid back? Use the calculator provided here. So we can use let's say problem 22. It's compounded annually, so compound interest. So here you have to use the compound annually formula. Compound. There are two compound formula. One is compound n times a year. Another one is compound continuously. So we are going to use compound n times a year. So let's do that. In this case, the amount borrowed is 49,000. That's the initial amount. That's the P. And then after that, time is 11 years. And so this is the formula we have to use. A equal P times 1 plus R over N to the power N times T. So in this problem, as you can see, the amount borrowed is 49,000. So P is 49,000. Time T is 11 years. Rate is 5%, which is, if you divide that 5 by 100, that would be 0.05. Always you need to divide that percentage. Whenever you see the percentage sign, you need to divide that number by 100. Compound annually, so the value of n equal 1. And how much you need to pay back, so that means what is the amount, the value of A. So 15,000, no, 49,000. 1 plus 0.05 over 1 to the power n times t, which is 1 times 11 is 11. Just you need to find this value, which is 49,000. If you divide this number by 1, it will be same thing, 1.05, and 1 plus that number is 1.05 to the power 11. Okay, that to the power 11. So use a calculator given here. So if you use this calculator, 1.05 to the power 11. So go back one more time, 1.05 to the power 11 equal, times it by 49,000. 1, 2, 3. So that's 83,806. And if you want to round it to the nearest dollar, it would be 807. So 83,807 is your answer. Okay. Next problem, 23. So this is the word problem. You can read the problem and you can find out the right formula. Manuel borrowed 8,000 at a rate of 12% compounded monthly. Assuming he makes no payments, how much will he owe after 6 years? Do not round any intermediate computation. So you need to use the same formula. Instead of principal 49,000, this time 8,000, rate is 12%, so that means it should be 0.12, and then compounded monthly, so that means the value of n would be 12. Okay, the same formula, but this time the value of n would be 12. So let me just add some extra blank pages here. So this problem 23. So the same formula, but the principal is 8,000. My pen is not working. I think my battery is not. Okay, so P is 8,000. Let me try here. And then rate is 0.12. If you divide 12 by 100, time is how many years? Time is given here 6 years, and compounded monthly, so there are 12 months in a year, so n would be 12. So how much manual has to pay back? That is p times 1 plus r over n to the power n times t. So that is 8,000. 1 plus 0.12 divided by 12 to the power n times t means 12 times 6, which is 72. So just type this number using the calculator here. It's 8,000 parentheses 1 plus 0.12 divided by 12, and then parentheses close, but I want to 12 parentheses close, and then power of that thing is 72, and that's our answer, which is 16,376.79 cent, nearest cent. So 16,376.79 cents. That is the amount manual has to pay. Okay. Problem 24. So a certain loan program offers an interest rate of 8% compounded continuously. Assuming no payments are made, how much would be owed after 7 years on a loan of 3,400? So this is the different formula now. It's a compound continuous formula. So just slightly different, not that big. This is problem 24. This time we have to use A equal P times e to the power r times t. We have given principal, that is 3,400. We have given the rate is 8%, so we need to divide 8 by 100, and time is 7 years. So time is 7 years. So how much we need to pay back can be found by multiplying this 3,400. Remember, there is e to the power this number 7 times 0.08 times 7. So I'm going to use the the calculator here. 3,400 times e to the power 0.08 times 7 equal 5,952.29 cent. You have to round it to the nearest tenth here. So 5,952.29. Okay, just using formula. Okay, the mass of a substance which follows a continuous exponential growth model, that means you have to use A equal P times e to the power r times t model, is being studied in lab. A sample increases continuously at a relative rate of 8% per day. Find the mass of the sample after 5 days if there were 32 grams of the substance present at the beginning of the study. So here you need to use the same formula because it increases continuously. So you have to use the same formula like this. At the beginning you have 32 gram. The P is 32. The initial amount is 32. And then rate is 0.08. And time is, what is the time? How many days? So time is after 5 days. So it will be 32 times e to the power, okay, let's go back, 0.08 times 5. So let's see, it will be 47.74, nearest tenth. So that means 47.7 gram. So remember, I just used the same formula, but this time this is not for the money, this is for substance, the mass. So the mass is equal to the the initial amount times it's growing, and growing rate is given and time is in days. So we are using the same because they are saying continuous exponential growth model, so we have to use the same formula. Okay. Okay, so just use the Alex for finding log 5 over 6. So here is the the calculator, and you can find log. Where is the log? I don't see log. Yeah, here's the log. Log 5 over 7. 5 divided by 6. Sorry, 5 over 6. What is that? It's a negative, and round your answer to the nearest thousand. So negative 0.079. Nearest thousands means after decimal there should be 3 number. 0.079, and you can see that after 9 there is a 1, so when you round it nothing will happen here. ln 28.1, so ln is here. Okay, ln is here 28.1, so that's 3.336. 3.336. The only thing you have to take care is when you round to the nearest thousand, you can see that after decimal you need 3 number, 1 2 3, but after 5 there is a 7, so you have to round 5 to the 6. Right, go to the next problem. Log base 7 1 over 7 is equal to -1. Rewrite as an exponential equation. If you want to rewrite log into exponential, this is problem 27. So you have to know this formula: log base a of x, let's say y equal to this, and we can always convert that to the exponential form, and the exponential form would be a to the power y equal x. So these two forms are equivalent form. So as you can see that this base is going here, this number on the other side is going on the exponent, and then x is going to the other side. So if you compare this equation with this one, here base is 7, x is 1 over 7, and y is -1. So if you try to convert that into exponential form, your form for this particular problem would be 7 to the power -1 equal 1 over 7. Okay, so here it's 7 to the power -1 equal 1 over 7. 1 over 7. And for this one, if you use the same formula here, you can see that a is 2, y is 5, and x is 32. So this is part A. Part B, if you want to convert that into the log form, y is on the exponent, so exponent is 5 equal log base is 2, and then x is 32. So 5 is equal to log base 2 32. So here log base 2 of 32 is equal to 5. So you just have to know that equivalent form and you're fine. So once again, rewrite this as a logarithmic equation. This is exponential form to the log form. You can see that e, if you have e, then you can use the log. If you use the both side ln, so it will be I'm going to show you here. Problem 28. It's 28. It's e to the power 9 equal y. Whenever you have e and you want to convert that to the log, just take ln, and then you can see that ln and e, they are inverse of each other, because ln means it's a log base e, so they will cancel out, and only thing you get is 9. So you can see that rewrite as a logarithmic equation, that will be ln of 9, ln of ln of y equal 9. Let me see, ln of y equal 9. So if you try to do the same thing here, if you take exponential both sides, e and ln goes out, so x will be left over on the left side. So that will be x equal e to the power e to the power e to the power x e to the power 3, sorry, e to the power 3. So log base 5, because the base here and this number is same, so it will be always 1 using the property. And here log base 2 of 1 over 32, you can change it to the same base. So what you can do is, this is problem 30, I guess. Log base 2, I can rewrite that 1 over 32 as 32 to the power negative 1. And I can change that 32 as 2 to the power 2 to the 2 times 2 times 2 times 2 times 2, 5 to the power negative 1. So basically it's log base 2 2 to the power negative 5, because log has the base 2 and there is a 2 to the power negative 5. They are inverse of each other. Eventually you are going to get negative 5. So it will be negative 5. Okay. Problem 30. This is the graph of log function. We want to use the left shift 4 unit and vertical shift 3 unit up. So left 4, so this 1 0 becomes left 4, which is negative 3 here, and then vertical 3 unit up, 1 2 3 here. So this point goes to here. Okay, so this 1 0 becomes left 4 unit, which is negative 3, and 3 up, 1 2 3. Okay, so once again, this is the log base 3x. It's a log function, and we're adding 2, so it's a vertical shift. So you have to know the log function first, and then it's just a vertical shift up. So if you 31, remember log base 3x can be plotted by plotting this graph y equal 3 to the power x. They are inverse of each other. So if you don't know how to plot the graph of log base 3x, plot the graph of y equal 3x, and then that will help you to plot the graph of log base 3x. That's the inverse function. If I do that, the graph of log base 3x, it gives me this kind of graph, and I can find some points like at 1 it would be 0, at 3 it would be 1, and then if I choose something 3 to the power something, let's say 3 to the power negative 1, which is 1 over 3, which is 1 over 3, then the value would be negative 1. So I can plot as many points I like let's say at 9, which is 3 to the power 2, that will be just 2. So this is the nature of the graph, which is inverse of exponential function. I can just switch the x and y coordinate of this function to get these points, and I'm just shifting those points 2 unit up. So whatever points you can see here, just take the x coordinate as it is and shift the y coordinate 2 unit up. For example, 1 0 becomes 1 2. So I'm going to plot that. 1 0 becomes 1 2. Plot it. And next point is like 3 1 becomes 3 3, because the x coordinate is same, the y coordinate is, you are just changing by 2 unit up. 3 1 becomes 3 3 3. So they are saying just plot 2 points on the graph of the function and also draw the asymptotes. So remember, for this graph, the asymptote is this line, which is x equal to 0. And since you are just shifting the graph up by 2 units, the asymptote would not change. If you are shifting this graph to the left or to the right, this vertical asymptote would also shift. But in this case, because we are just shifting the graph up, the vertical asymptote will be same. Now we just have to click this one, and that will give us the graph of the log function. Okay, so here you need to plot the graph of log base 3x plus 3. Remember, this is the same as the previous problem, log base 3x n plus 2. But first of all, before shifting your graph, you have to shift the graph to the left, 3 unit left, 3 unit left. So these points, you have to shift them 3 unit left and then only up. So I'm going to use the previous graph. I'm going to use the the points from previous graph here, like 1 2 becomes, if you shift 3 unit to that side, this becomes 1 2 3 negative 2 2, and this 3 and 3 becomes 0 3. So write it down, because we already have this one. So I'm just going to use this graph here. As you can see that uh, this vertical asymptote is x equal to 0, and we're shifting this graph 2 unit to the left for the next problem. So the vertical asymptote becomes x equal to negative 2. Okay, that's the first thing. So here what is that? The vertical asymptote becomes x equal to negative 2. Okay, and then point is, if you go back here, the point is this I'm going to write it down, this points 1 2 becomes, because we're shifting that point 3 unit to the left, that becomes negative 2 2, and 3 3 becomes 0 3. So as you can see that the very same graph we're plotting here, but because of this x plus 3, we're shifting that graph 3 unit to the left. So first thing, the vertical asymptote is this one, and now for the point, the first point I got is negative 2 comma 2 by shifting 1 2 3 unit to the left, and another point is 3 3 becomes 0 3 by shifting the graph, the previous graph to the left 3 unit. Okay, so graph, and just choose this one, and here's a, what is that? Okay, negative 3. So that should be, what about that? Negative 3 is here, negative 3 is here. So okay, that's the first point. Okay, what I'm doing wrong here, let's go back here, 31. I need to use these points 1 2, and if I shift that point 3 unit to the left, that becomes negative 2 3, negative 2, no, 1 2 becomes negative 2 2. That's good. This 1 2 3 3 3 becomes 0 3. So let me go here. So negative 2 2 0 3, and now I need to choose the vertical asymptote, which is x equal negative 3, this one, and this is the first point, and this is second point. Okay, now I need to find the domain. Domain is, as you can see, that it's starting from this vertical asymptote, which is negative 3, but not including that vertical asymptote, so that is negative 3 up to infinity. And then range is, as you can see, that it goes down to the up. So for any log function, the range is negative infinity to positive infinity. So you can see, remember, this is log function is this is the inverse of exponential function. So the domain and range will just just switch. Okay, so the last problem, find the domain of the function. For finding the domain, whatever you see inside this parenthesis, make that thing, find the domain of that, make that thing greater than 0 and not equal to 0. What does that mean? Let me just, I need one extra page here. For finding the domain of log function, we know uh, this is 33 log base b of anything. The domain of this thing is this anything should be greater than 0. So it cannot be 0, it cannot be negative. So here in this case you can see that anything is 5 over x minus 4. So we need to find out where this is greater than 0. So the first thing is this x cannot be equal to 4 because that makes things undefined. So the first thing is x minus 4 cannot be equal to 0. That means x cannot be equal to 4. That's the first requirement. Okay, now we have to solve, where this function would be greater than 0. If you try to look at this function here, the zeros of this x minus 4 is here. X minus 4 is x equal to 4, the function would be undefined. There is no 0. So now you have to look at the value of this rational function on the left side of 4 and on the right side of the 4, because at 4 the function is undefined. So we need to find some testing point from these two interval. So for this function to be to solve this inequality, just find some testing point. I need one extra page. So just find some testing points. So I'm going to pick 0 from here and pick 5 from here, and I'm going to check. Let's say this is the function f of x is 5 over x minus 4. So I'm going to check the value of the function f at 0, which is 5 over 0 minus 4, which is negative. So on this interval the function would be negative. I'm going to check the value of the function at 5, which is 5 over 5 minus 4, which is positive. So on this interval the function would be positive. So as you can see that we're looking for this thing to be positive, and we know for sure that on the interval 4 to infinity, that thing would be positive, and that helps us to find the domain of the function. So the domain of the function would be 4 to infinity. Make sure that this thing inside the parenthesis should be positive, and on this interval this thing would be positive. So that's all. So if you have any questions, you can feel free to email me, and all the best.